Hey there, friends. NASA just launched the world's biggest and strongest space telescope a few days ago. The name of it is the James Webb Space Telescope. You can kind of move through time with this. You can't really go back in time, but this gives you a look into the past. This telescope can look back millions or billions of years into the past. I'm not just talking about events from the last 5 or 6 years, 13 billion years to be exact. The Big Bang happened 13.8 billion years ago and was the start of the world, which means it can see back 13 billion years, about 0.7 billion years after the beginning of time. But how is that possible? Come watch this and help us understand what's going on.
Liftoff from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe.
Nature has this way of being even more creative than we are. So we have always been surprised by what we see in the sky. That's why building a telescope has always been interesting.
The coolest thing about this telescope is that it was mostly made to pick up infrared light. Normal telescopes let you see the bands of lights that we can see when we look up at the sky. The kind of light you can see. Do you remember what you learned in school about the electromagnetic spectrum? There is a wide range of electromagnetic waves. There is a small range of visible light in there, along with X-rays, UV rays, radio waves, and microwaves. The kind of light we can see. Any store can sell you a telescope, but they can only help you see light with a range that your eyes can see. Light that can be seen ranges from blue to red, with red having the longest wavelength. You should also know that electromagnetic waves can easily pass through anything as long as the wavelength is big, like the radio waves, the radio that you listen to. Radio waves can have lengths of more than 1,000 kilometers. So you can even listen to radio waves that go through houses. Infrared light has longer wavelengths than red light. We can't see infrared light with our normal eyes though. This picture shows the benefit of using a telescope to study infrared light. It was the Hubble Space Telescope that took the picture on the left. It was the strongest space telescope we had ever had. You can also see the gas clouds that are growing. We'll be able to see what's behind the clouds and dust though, because infrared light can get through them. The picture on the right is what we think the James Webb Telescope would let us see. You could say that we'll get an HD view, which is better. Infrared waves are sent out by anything that gives off heat. Infrared waves are sent out by people, animals, the sun, and fire. Thus, the reason why troops often wear night vision gear. These glasses basically pick up infrared light. This is what you see through the night vision glasses. Cameras that use infrared light pick it up. It will be possible to pick up and study infrared waves because the telescope will be able to see planets, galaxies of stars, and stars themselves. All of these things give off heat. Another benefit of infrared is that when a telescope looks at stars that are billions of kilometers away, the light from those stars has already traveled such a long way that the wavelength of the light has been stretched. This is because the universe is slowly expanding. It makes the wavelength longer. The name for this event is the red shift, that the light's wavelength has grown a little longer and moved toward the color red. The bigger the mirror on a telescope, the more light it can gather. There will also be a much higher quality of the picture we get. This is how big the Hubble Space Telescope's mirror was. The James Webb Space Telescope's mirror is right next to it. The whole mirror is covered in 24-karat gold, because red light bounces off of gold the best. I said that everything that gives off heat also gives off infrared waves. As soon as the James Webb Space Telescope starts to work, it will give off some heat. There will be some infrared waves coming from inside the camera. We won't be able to get good, clear shots because it will mess up the waves coming from the galaxies. So that doesn't happen. The James Webb Telescope will only work when it is minus 223 degrees Celsius outside. This is how cold it has to be for it to work. The temperature on Earth has not dropped minus 89 degrees Celsius. How did they keep this camera so cold? It's possible to do in space. It is possible because space is very cold. When it's not lit up by the sun, it would get very hot very quickly if sunshine hit you in space. The same thing happens on the moon. Since the moon doesn't have an atmosphere, it could get as cold as minus 170 degrees Celsius there. But when the sun comes out, the temperature goes up to 120 degrees Celsius. This telescope has a lot of trouble with it. As soon as sunshine hit this camera, things would start to go wrong because they would get too hot very quickly. That's why they had to stop the sun. A sun shield has been put on this James Webb telescope to stop this trouble. It's as big as a tennis court and shaped like a kite in order to keep the camera safe from the sun. A unique material called Kapton was used for this. Several kinds of materials were tried out to see which one would best keep the telescope cool and block the sun. It was later found out that Kapton was made in a lab. There are 5 levels of Kapton in this sun shield. Each layer is smaller than a head of hair. There is a space between each layer that is empty. Therefore, it could be made more useful. The other thing is that each layer has an aluminum covering on it, and there is doped silicon on top of the 2 layers that are closest to the sun. The Hubble Space Telescope was put into space very close to Earth. Hubble goes around the Earth and is close to it, but this is going to be put in place 1.5 million kilometers from Earth. For this telescope to work better, it is important to keep this point away from the sun as much as possible so that it doesn't get too hot or too bright. The L2 point is also unique because it keeps turning around the Earth. During the revolution, the sun will be hidden. Check out the path it will take. The sun will be hidden by the Earth's shade. It's like how you can't see clearly when you look at something facing the sun. It's like putting your hand over the sun. Plus, you can see better. It holds true for the lens as well. NASA says that the whole process of making it and sending it is so difficult that they have thought of more than 300 problems that could happen. A list of more than 300 possible fails. If even one of them comes true, the whole project is over. This project cost $10 billion. To make this project possible, NASA had to cut money from other study projects and give it to this one. The European Space Agency, the Canadian Space Agency, and NASA are all taking part in this. Scientists are hopeful that this will help them figure out how stars and galaxies formed after the Big Bang. You can look 13 billion years into the past with this telescope, as I told you. The Hubble Space Telescope could only see back 1 billion years to the time before the Big Bang, and that was about 12.8 billion years ago. It can see back 0.3 billion years to the time of the Big Bang, though, as you can see from this picture, when the first stars started to form. You might wonder how it's possible to see into the past. It's very easy to say. It takes a while for the light to go that far, and a lot of time will have passed by the time the light gets from one place to another, especially when it comes to such long distances. About 8 minutes pass before the light from the sun hits Earth. In other words, if the sun faded all of a sudden, it would take 8 minutes for people on Earth to notice. While we look at the sun, it's kind of like going back in time 8 minutes. In the same way, use this reasoning on a big scale. When we look at stars and galaxies that are millions of light years away, either through a telescope or from Earth, we see them as they were millions of light years ago. Since the universe is so big, there are stars 13 billion light years away from us. It would take 13 billion years for their light to reach Earth, so what we see now is what happened 13 billion years ago. We can see a bit of past this way. In theory, this means that if we go 100 million light years away from Earth, we could also move to a world 100 million light years away from Earth, and we build a very strong telescope on that planet. When we look at Earth through it, we'll see it as it was 100 million years ago. We're going to see dinosaurs, but this won't work because it will take a lot longer to get to the other world than the years we can look back on. In other words, if teleportation becomes possible, we'll be able to see events happen on Earth and would be able to go back in time. More than that, it will be interesting to see what new worlds the James Webb Telescope finds. Will it be able to find a planet that is like Earth, where it's possible to find life? We'll see in time. I hope you enjoy this video. If you are interested in space, you can also watch this video about space tourism. And if you click on this playlist, you can see my other films about science. Come see me in the next show. Thanks a lot.